Hey, today we're going to go over wiring diagrams, and I want to demonstrate on something relatively simple how to read a wiring diagram and how to make sense of what you're seeing because you understand the fundamentals of what you're looking at. Wiring diagrams are extremely useful. I would say 75% of the time when I'm working on a vehicle, before I go look at theory and operation or actually look up how things work, I'm looking at wiring diagrams first. And the reason for that is there is so much valuable information in a proper wiring diagram. Now, these diagrams are made, they're redrawn from factory OEM wiring diagrams. They're much simpler to read. They're not always accurate, but I'd say they're 95% accurate. And they're like wiring diagrams on easy mode is the way I think of it. They get much more complicated, much more difficult to read. I started reading wiring diagrams way back in the day in paper manuals. They didn't have the colors of the wires in color. Everything was notated out. But we're just going to go through these and start with the simplest of simple, and then I'm probably going to do 5 to 10 videos on this depending on what kind of interest there is, and we can get into some obscenely complicated circuits if you guys want. But for today, we're going to start with just a extremely simple, not extremely simple, but a relatively simple 2011 Chevy Malibu with a 2.4 liter. We're looking at the starting circuit. So we're going to walk through that. Just try to follow along if you can. And if we get to a point where you don't understand anything or you have questions, feel free to ask questions in the comments and I'll get back to you when I can, because I don't want to confuse anybody. But I want to demonstrate how I go through these and what goes through my head as I'm looking at them. So, we may or may not be on the same level as we go through this, but my point is to demonstrate everything you can get from a wiring diagram and how useful they are and why it's worth learning how to read them properly. So with that being said, let's get started. Let's look at the starting diagram on here. So the first thing we're going to look for is where is the starter. And if we scroll down, you can see here's a starter motor in the lower left-hand side. And you can see not only is it labeled starter motor, it's got a solid black box all the way around it, which means all of the wires that are going to this starter motor are expressed in this one diagram. And you can see, for example, where the automatic transmission is next to it here. It says automatic transmission, but then we have a dotted line all the way around the box. What that tells me is there's many more, or at least one more, circuit going to the automatic transmission. And we know from experience that there's many more circuits going to the automatic transmission. But these are all the ones that whoever wrote this diagram decided was relevant to the starting system circuit. So now, let's go to the battery. Let's start there. And you can see there is a direct lead off of the battery to the starter motor, which anybody that knows anything about cars knows that's pretty normal, right? There's almost always a direct lead. And in this case, it's in the diagram. And then there's actually a lead off the starter motor B+ terminal, a fusible link that goes to the generator. So they don't necessarily need to put this in the diagram, but they're nice enough to put it here. And you can see there's a fusible link here that goes to the generator, which is good to know because I've actually seen that several times where somebody has replaced a starter motor, not hooked the generator wire back up, and all of a sudden they have a no charging situation and they're unsure why. Because sometimes, it's dark and it's hard to see up there, and if that wire is not out where you can see it, it's easy to miss. I've seen that happen a few times. Also on the starter motor here, you can see a couple of hand-drawn symbols. So we're going to go over this quick. This one on the B terminal here, this is a normally open switch. And you can see that's expressed with a line and an arrow and 3 dots. And it's in the normally open position, so it's normally open. And here you can see 2 sets of inductors. This is an inductor symbol. A lot of times that inductors are often solenoids or electromagnets. So you can see that that is a solenoid, and there's 2 circuits there. The reason there's 2 circuits is one is a pull-in circuit and one is a hold-in circuit. And you can see how that works. And I'm not going to go over that now because I don't want to get everything too confusing, but you can see that it demonstrates there's 2 separate circuits in that solenoid, one to pull in, one to hold in. One gets grounded through the starter motor, and the other one gets grounded directly to ground. And you can see from the battery here, there's 2 points of ground to be concerned with, and they give you the ground identifier that you can search in the service manual and look for a location. And then there's another red lead that comes off the top of the battery, off the positive side, all the way up here to the underhood fuse block. Through a starter fuse, through a normally open relay, and we know that, so we already discussed that, and then out, back to the starter. So we know in order for this vehicle to start, this relay has to be closed. And you can see here's another inductor symbol or electromagnet signal. So we know this is normally grounded here at G109. So then we know somehow it has to get voltage and current here at 85 in order to feed this side of the relay to close the switch and engage, put power here to operate these solenoids to close the starter solenoid contacts and make the starter motor run. So we know this has to function here in order for that starter motor to run. So this is where I would want to test, but let's say we didn't have our signal here at 85 when we tried to start it. So we didn't have voltage here at 85 to operate the solenoid side of the relay or the control side of the relay. So let's follow this wire back down here. And there's actually 2 sets of labels here at the ECM, or the engine control module. So depending on which engine is in it, whether it's the 3.6 or the 2.4, there's 2 different identifiers of which connector and which pin. So you can see this is X1 for either the 3.6 or the 2.4, and then pin 26 if it's a 3.6, and pin 32 if it's a 2.4. And we know this is a 2.4. So since it's a 2.4 liter, we're going to be looking at pin 32 at the ECM to put power out to that starter relay coil control, which is what controls the starter relay. So what makes it do that? If we're not getting power out here, why not? Well, you can see there's a few other circuits here. One is high-speed communication, which we're going to ignore for a second, and we're just going to go down to the ignition lock control signal. And what would that possibly do? Well, you can see it goes down here, and again, this is split for either the 3.6 liter or the 2.4 liter. And if we follow the 2.4 liter, we know it's an orange and black wire that goes through connector X108 and pin E at that connector. So now we can go into the service information if we needed to and look up that connector and see if maybe that's an easier spot to test than getting access to the transmission. But let's follow this, because we don't even know if there's power coming out here or what's going on here. So this wire goes down into the transmission assembly and goes through the control solenoid valve assembly, in and out, and then back over and through the transmission control module. And again, just a complete circuit into the control module and back out. And then it goes into the control solenoid valve assembly again, and then back out here. And you can see the connectors are here again. And where it says 2 and 1, you can see these are footnotes up here. Where it says 1 would be the 3.6 liter, 2 would be the 2.4 liter. So we know this goes out on this white or blue wire over here through the automatic transmission internal mode switch, which is normally closed. That's important to understand here. This is a normally closed switch, and over here by the starter motor is a normally open switch. So we know it's normally closed. So in Parker neutral, that switch is closed, and then that connects that wire to this gray or black wire, which goes back through the control solenoid valve assembly, and then back out, and then to the transmission control module, which supplies this with a permanent ground. So we know, based on our knowledge of electronics, whether this is 5 volts or 12 volts, I don't care. What I do need to know is normally in Parker neutral, this wire is pulled low to ground. So whether it normally has 5 volts, normally has 12 volts, normally has 8 volts, I don't even care. What I need to know is this wire being pulled to ground, which if we're referencing battery ground, we're looking for 0 volts on this wire. And a lot of times, anybody that's doing this kind of diagnostics will probably have a scan tool hooked up, and in the ECM, there will be a PID or a parameter in the data list that tells you whether this ignition lock control signal is grounded or not. And that's important to understand because you could really spend a lot of time not understanding that. And again, we're looking at one page on one diagram and getting all this information. So back up to the high-speed LAN, or the high-speed GM LAN, which is CAN bus. So we know if this is pulled low, that's not going to stop our starter from operating. So what else could stop our starter from operating? Well, we have computer data here, and we have a body control module. The body control module acts as the ignition switch. So you can see there's a physical ignition switch that are all computer circuits here. So it's a very, very low current system because it's a 2 amp fuse that runs the ignition switch. And you can see when the ignition switch is in the start position, there is voltage switched on this switch to start, and there would be, I believe, this connects the two. So you can see we have, that's actually the resistor in the ignition switch. So you can see here, this switch, when switched to run or start, when it's in the start position, there's a resistor here, and it's looking for this value. So actually the voltage comes out on this white wire, up through this resistor, or through the run, or through the key-in switch over here. And then when this is turned to start, this black and white wire will drop the voltage across the resistor to a specified voltage that this logic controller in the BCM is looking for. And that's for anti-theft purposes. And you can see when it's this side here, when it's turned to start, it connects voltage through the start path, and the run path in this case, down to the ignition 1 circuit. And that allows it to turn on the ignition 1 accessories, or everything that's on the ignition 1 circuit. And then once it sees the ignition key resistor, it's going to know that it can start. That's when it gets told, okay, while we're in the start position, start the engine. So then the BCM goes, okay, well, the ignition switch is in the start position, it passes the anti-theft check, now it's going to put communication out on the high-speed GM LAN to the ECM. The ECM goes, okay, we're clear to start, and is the transmission in Parker neutral? Is this wire grounded? It sure is. So then it's going to put 12 volts out on this starter coil control. It's going to go up to this relay. It's going to close this. It's going to power this control side of the relay because this is a permanent ground. It's going to close this set of contacts. So now we have voltage flowing through the starter fuse. Current's going to flow through there, out the purple wire. We will have 12 volts or battery voltage here at the S terminal, and current will flow through the solenoid closing this switch, which allows current to flow through the heavy B plus lead to the starter motor and crank the engine. And that's it. Then the engine cranks over and starts, hopefully, right? As long as nothing else is broke. But that's how we get there with a one-page diagram. Simple, straightforward. Now, of course, I'm a little rusty on the anti-theft logic in the ignition switch for a 2011 Malibu. So if I do, and I could learn about all this, but if my transmission, basically my ignition lock control signal isn't being pulled low, I don't even care about the immobilizer stuff. So what I'm really going to look for in this case is I'm going to hook up the scan tool, going to get to the engine control module, see if the BCM is sending a crank command to the ECM, and see if the ignition lock control signal is grounded. So the ECM has to know it's in park or neutral, and it has to be told by the BCM, hey, this car's not being stolen, it's okay to start. And then once it gets all that information, it's going to put power out on the starter relay coil control. That's going to activate the relay, and then in turn activate the solenoid, which will activate the starter motor. Again, this is a very simple, reasonably simple, straightforward diagram. That's why I wanted to start here. And you can see there's more connections on the BCM because of the dashed lines. There's more connections on the ignition switch because of the dashed lines. And there's a lot more information in here, but I wanted to start with something relatively simple to explain how I'm going to work through these to understand how the circuit works. It's a little bit of simple, basic reverse engineering because once you understand the engineering principles behind what it takes to make that motor turn, there's only so many ways to make that happen. So then it's either deducing how this all works or looking up the information. And if it can be deduced easily, like in this case, why waste the time looking up a theory and operation to understand how it all works? So with one page, the engineers can get across a simple theory and operation, the circuits that are intended to use for this starting circuit, and how they all function. Now, of course, they're not going to give you everything on here, and the factory diagrams actually include quite a bit more. You can see a few things like circuit IDs here. These are usually searchable within the service information. So if you wanted to know where else this 2501 circuit went, or 2500 circuit, or this 1390 circuit, maybe you wanted to see where else it went or what other articles apply to that circuit, you can look into that. And sometimes you can even find theory by searching the circuit numbers. But again, these things are packed and full of useful information. A lot of times it's a lack of understanding the fundamentals that makes these so difficult to understand. So that's why having a good grasp of the fundamentals will help you understand how things work faster so you can get to just fixing the problem. But again, you can't fix the problem if you don't know how it works. So that's why we're here going through this diagram. So hopefully I can try to convey how I'm able to look at a wiring diagram, decide how the system works, and then get to testing. Where is the easiest place to test? In this case, either the start relay or hooking up a scan tool and looking at my ECM data. And chances are I'm going to do a pre-scan on this vehicle. I'm going to already have the scan tool hooked up. So I'm going to hook up the scan tool. I know it's a no crank. I'm going to do a pre-scan quick, look at any applicable codes, save the pre-scan for the customer, and then I'm going to look right at the ECM data and see, is the BCM telling me we're passing security test? Do I have a command to start from the BCM? Am I in neutral or park? Does the ECM know I'm in neutral or park? And then is it putting out power to the starter relay control? A lot of times there's even in the live data, it'll even tell me if it's turning on the starter relay control, and then I can go up and verify that at the starter relay. And there's a whole variety of tools, from everything as simple as a test light to some really nice relay testing tools. But either way, so the smartest place in this by looking at the diagram, the smartest place to go to test at would be the start relay 31, or have the scanner hooked up and see what you see with the scanner looking at data and codes. And in this case, more importantly, the data. So I hope this helps. I know I ran through it kind of quickly, but this is how we do it in the field with a flat rate mentality. I'm just trying to get this car fixed, so I'm going to run through this as fast as I can, make sure I properly ID how every circuit works that applies to what I'm trying to see what works or doesn't work, and then apply that to the most applicable testing method, and then get on the vehicle and get testing so we can get this problem solved and move on. So anyway, I hope this helps. Thanks for watching. If you want to see more wiring diagram videos like this, let me know. I plan on making at least 2 or 3 more. And then if you guys wanted to get into some really outrageously complex circuits, we can do that. And obviously, the more complex we go, I'll slow down and explain it a little more thoroughly. But like I said, this one's basic, fairly straightforward. If you need to, watch it a few times. Watch it in slower speeds to get a good grasp of what's going on here. If you have any questions, please comment in the comments and ask questions. I'll do my best to answer. Thanks for watching. If you like what you see, like, subscribe, and all that good stuff. Thanks.